Welcome to another unit in business mathematics. This time I'm going to talk about the so-called effective interest rate and how to calculate this. Effective interest rate, that's the interest rate which actually becomes active when we work with sub-period compound interest. In other words, if we have sub-period interest payments, we get more than one payment per period. So due to the compound effect, by the end of the period, we will have more in our account than we would have gotten if we only had one interest period. And if we want to know by how much our investment actually increased, depending on the interest rate and the number of sub-periods, that's when we're going to use the effective interest rate. So here we have interests paid, as I said, intra-yearly. Could be monthly, quarterly, weekly, whatever. And we can take a look at this topic with an easy example to start with. So here, basically, we just assume we have monthly payments and the yearly interest rate is 6%. So the question then could be, what would be the actual effective interest rate or the real yearly interest rate underlying this saving or this investment scheme? So for this, we're going to take the formula we already know for sub-period interest payments. We insert as the number of periods 12. So after 1 year, we actually, if we summarize this here with an interest rate, an assumed or nominal interest rate of 6%, we get that the capital after 1 year is actually 1.005 to the power of 12 times the initial investment. Well, if we only had one payment, we would have gotten 1.06 times K0. So what we can do now is just take a look what the 1.005 to the power of 12 actually will result in. For this, we're going to take it and just subtract 1 from it, giving us a value of 0.0617 or 6.17%. So the effective interest rate here is not 6%, that's the nominal one. The effective one is 6.17%. So in this case, the effective one is always larger than the nominal one. Well, here we already have a simple formula for this. We can simply divide the capital after the first period by the initial capital and subtract 1. Here this gives us the factor 1.005 to the power of 12. If we want to do this in an even more general fashion, we can also deduce a formula from this. That's what we're going to do in this slide. So here, as a general formula, we have the effective interest rate is just 1 plus I divided by t to the power of t, whereas t is the number of sub-periods considered here, and then minus 1. And actually, well, the expression in parentheses to the power of t, that's nothing else than the k1 divided by k0. So same thing as before. So if we then also consider that we can use this not only for a 1 year period, but also for more than 1 year. So we could just replace K1 with Kn and then simply take the nth root of this. Gives us a similar idea. Here, in this regard, it's more or less like an average interest rate. If in this regard, however, well, if we had only 1 year, would have exactly the same thing as before. So this is just expanded for multi-period perspectives. Well, for this, to close up this session, an additional example. So for example here, we have a deposit of 10,000 euros. Interest rate is paid yearly. And after 5 years, our deposit is valued at 13,000 euros. So the question could be, what's our average interest rate? So for this, we simply take the fifth root of 13,000 by 10,000 minus 1, giving us 0.054. So an average interest rate in this investment would be 5.4%. Well, in this regard, we see the idea behind the effective interest rate not only works when we want to relate nominal interest, yearly nominal interest, to effective interest if we consider subperiods, but it can also be used to calculate average interest over a multi-period time frame. Well, that's then all there is to this unit, so I hope you enjoyed it, and well, see you soon.